Hi everyone, hope you're all doing great. In this course, we'll learn everything necessary for you to start from level 0, where you might not have any idea about coding, to a stage where you can directly implement your data science skills in real life scenario. But before we move forward, we need to understand the role of coding in data science. So, coding is merely a tool that helps us execute the process of data science. The most important part here is our sense of logic and our business acumen. But to get started, we need to learn coding and we need to implement those codes to exercise our visualizations and logic. Well, that said, let's dive into the course. But before starting with anything, let's understand, why do we need to learn programming at all? The most basic the important thing for it is that it teaches us to think in a structured manner, to let go of the declutter and make everything in a channelized way. Now, computers, as we all know, are built to make our lives easy. However, they can only be communicated to via their own language, which is codes. For example, in this course, the medium of learning is English. Amongst all of you, someone might be speaking Hindi, someone might be speaking Bengali, some other might be speaking Gujarati, Punjabi, and all. But there needs to be a common ground to which we can communicate. And here, that is English. Same for computers. They learn the language of codes. Now, coding can have different languages as well, like C, C++, Java, Swift, Python, R, etc. Codes are basically nothing but stored instructions, a sequence of stored instructions that basically directs the computer what to do. They're written in their own form, and we need to learn this particular form and communicate with the computer. And now, with the advent of different programming languages, Python, for example, it's very similar to our English language. Again, it also provides many facilities for which the ground language of our this course would be Python. So let's understand the facilities that Python provides. Python is basically a very simple language and is therefore very easy to understand and learn for beginners per se. Even for people coming from other programming background, it would be just a jiffy that you learn Python. It provides some excellent packages of AI or machine learning, whatever you want to call, some of which are Matplotlib, Seaborn, Plotly for visualization. Plotly provides a dynamic visualization. We will learn all of this in this particular course. NumPy and SciPy for scientific computation. Scikit-learn, which helps immensely in machine learning. Scikit-learn is such a package which has developed machine learning. We just need to import those particular machine learning models and run them. And now, for deep diving into the machine learning process, we need to learn how those machine learning models were created. We'll learn everything in this course as we go. TensorFlow for deep learning processes. Most importantly, Python has an extensively used big community. So what is the role of a big community? Let's say it is something that is certain of. When you learn to this course, when this course ends, you might have a basic or a mid-level understanding of what data science is. You might be able to contribute to real-life scenario data science projects. But the more you learn, the more you go forward, you will definitely come across different barriers which needs to be cleared. You might find yourself engrossed in some confusions and everything. That's when the role of the community of data science or Python per se comes into play. There are different websites, Stack Overflow, for example, where you will find enormous people posting questions and these questions being answered by your peers. Whenever you find yourself in some trouble, Google it or post your questions in such kind of websites, Stack Overflow, for example, and you'd instantly find those questions being answered because of the presence of such a wide number of people using Python. That's a very beneficial part that Python has. Now, Python is basically a general purpose. Again, I'll be making you understand what these terms are. So general purpose, what do we mean by that? General purpose means that it is not specific for any particular domain. Python can be used for, let's say, analytics, web development, app development, gaming, and many more. Robotics, for example, AI, IoT, many more. It's also high-level programming language. What do you mean by high-level? High-level means it's very near to the human language. As we learn Python, we'll understand it's nothing but simply understanding English language. If you have coded in any language, or if you know about the languages used in the 1900s, you would understand how difficult they were compared to Python. Those were called low-level languages. All right. It is also an interpreted language. By interpreted, we mean that the script can be executed without any compilation. People coming from any other background like Java or C, C++ would understand that a compiler is must for these languages. For Python, we need no compiler. It is executed without any compilation. And finally, it is also a dynamically typed programming language. What do you mean by dynamically typed? It means that it automatically identifies the type of the variables. For example, in other programming languages, we need to define that this particular variable is a int variable. Int means integer, or a string, or let's say a float, or something else. But in Python, we did not explicitly define what kind of variables we are using. By the value of the variables, it would automatically identify what kind of variable it is. We'll understand everything. And it was created by Guido van Rossum in 1991. That's a brief about Python. Now, the advantages that Python brings is that, first, it is an open source software. That is, it is free to use. We do not have to pay any money to use Python. It is a cross-platform library. That is a software, not a library. That is, it can be run on different OS, not specific to Windows or Mac. It can be run in others as well. It is integrable with other programming languages like C, C Sharp, etc. Now, this is a very important point. Why? Because Python, being a high-level language, is pretty slow. And you would find this enormously in the industry, that Python is very slow. Why not use C or C Sharp? Because these are fast languages. Especially if you know that in gaming, C Sharp is widely used because of the fast reflexes. Now, Python has done an amazing thing, which is it can be integrable with other programming languages. So NumPy, for example, is a library in Python which is integrated with C, therefore making the process quite faster. Python has its own advantages, and being integrable with the faster programming languages makes the execution process much faster as well. All right. It is also an object-oriented language. Object-oriented language is nothing but use of class. It creates a blueprint of the entire thing. We will learn everything about what object-oriented programming language is. It's very difficult to answer this particular thing in a couple of lines. We'll have a definite chapter for what object-oriented programming is. Just understand, it makes our code much easier. All right. Next, it has a rich library and community that I already have explained. And my favorite part, it uses fewer lines of codes. To the best of my knowledge, I've found Python using the least lines of codes to any other languages in the world right now. Now, applications of Python. It can be used in web applications, GUI, that is graphical user interface, for mathematical computation, data science and machine learning, that is analytics in short, game development, automation, where it finds it's another important use, and many more. There's literally many more applications of Python. Now, to get started with Python, we need to install some particular software so that we can actually use it. See, the first thing that we need to do is we can install Python right away and start using our command prompt to handle all those stuff. But since this course entails learning the data science process all in all, what I recommend is we install a software called Anaconda. There we'll get many small softwares, one of them being Jupyter Notebook. And Jupyter Notebook is the bread and butter of data scientists. We'll understand. Let's now understand the process of installing the same. And with the course, as it progresses, we'll understand everything that I'm telling about. So, quick notes. Preferably the version 3.6.8 should be installed because it handles all the data science libraries pretty well. But however, the latest version that I have installed now entails handling all kind of problems pretty well. So I recommend using the latest version. I'll just show you the particular process of installing the latest version. If not, I have already given the links of the version 3.6.8 for Windows and Mac as well as Linux, both for 64 and 32-bit. One more quick note that if your laptop or computer per se has poor processing power, that is, you are using an old laptop or a computer, consider using this particular website called Google Colab, because you will need nothing except your good internet connection for that, and everything will be running smooth and efficiently. Okay, now let me go to the internet and show you all the process. Right, we are now in my Chrome. So let's say you want to install Anaconda. You have a decent laptop and you want to install Anaconda. Just type in Anaconda, A-N-A-C-O-N-D-A, Anaconda. Go to the first link over here. Press on the download button. It would start downloading. Based on your internet speed, it would take some amount of time. It's a relatively larger file, 621 MB. Now, while it downloads, I've already downloaded this particular file. I'll show you. So once you've downloaded Anaconda, go to your download section, the folder where you have actually downloaded it. You'll find this exe file. Double click on the same. It would take a while to load. Now, as instructed earlier, click next, I agree, next, just me, and then choose your destined folder. Advisable, use the C folder as it is, and go on clicking next. I won't be doing the same because I already have it installed. But for you guys, just go on and install it. Now, once you install the same, there would be asked if you want a startup icon. So click yes if you want it. If you don't, just click it no. How do you get access to it? If you have this icon on your start menu, then you can just double click on it. If you do not, click on the start bar, click here Anaconda, and open. All right. I would highly recommend it. You pin it somewhere down here so that you can get a quick access to it every time you use it. Once you click on this particular icon, this particular UI opens. You have a lot of other software here, but what we'd be using is the Jupyter Notebook, this particular thing. So go here, click on launch. Let it launch. Okay. So now it says localhost 8890. That is, it's running from your PC. This is the entire thing of the place where the folder has been installed. Now what I have done is I've created a random folder. So that, and I have numbered it 1, 2 like that, so that I can get use into that. You can use this particular technique, or if you just want to create anywhere here, create a folder and start using the file as it is. So I'll be clicking on here. Now let us create a Jupyter notebook. What I'll do is, you'll get this interface, click on new. Here you get all these options. Python 3 IPy kernel. It means a Jupyter notebook itself. Text file is something that is .txt that we use in Notepad. Folder is this kind of things when you wish to preserve your files in a folder in a particular name. Terminal, you don't need to use it right now. When and where we'll be using, I'll let you know. What we'll be doing here is clicking on this particular Python 3 IPy kernel. Separate tab opens over here. Or you see this particular tab here, untitled as it is called. Now you might want to change the name. Let's say I change the name to demo. How do you do that? Click over here, demo, and click on rename. That's all. Now you might want to write your codes, whatever it is. So let's say I write a basic Python code. I'll explain how it is done just for the sake of understanding. Let's say I'm writing b equals to 12, a equals to 3, and let's say I'm adding all these 3. So sum equals to a plus b, and I'm printing the addition of a plus b, that is 15. Okay, so what did I do? You might want to create on run. Then what happens? Your file gets executed. Or if you want to use your keyboard keys, what you do is you press Control plus Enter. That is, again, can be done. Control plus Enter. One more key that you should be aware of is Shift plus Enter. What it does is same as Control plus Enter, but it also creates a next cell below it. Now let's say you are not comfortable of using the keyboard, then you can use all the commands over here. So for executing, create on run. For new cells, create on this plus icon over here. For deleting a cell, press on that particular cell and click on this particular Caesar icon, and your cell gets deleted. Okay. There are many more features to be used. We'll understand as we go along coding. For now, let's get our knowledge limited to this particular part. All right. Okay. One more thing. If you want to change the name from the outside, what you can do is click on this particular tile. First, shut it down. So the green icon gets closed and it's converted to a black icon. Now click it again and then click on rename. And you can put your name, whatever you want. Let's say demo2 and then rename. So your file gets renamed as demo2. That is something you can also do. All right. Now let us learn the basics of Python. Start with it and we'll understand how to use the Jupyter Notebook with time. Those were the basic things that I let you know. All right. Now, let me grab my PPT very quick. All right. So the Python fundamentals. The first thing that I want you guys to know is that the concept of variables. Okay. So contrary to a lot of concepts that we have learned in past. Maybe if we belong from a coding background, that variables are containers wherein all the variables, all the values are stored. This does not really apply to Python. So how does people make you know the concept of variable? It is a container and you put some value, let's say 42 inside it. This container, we call it as A, which is a variable, and it contains the value 42. While it is true for many other programming languages, this is totally false for Python. In Python, variable is nothing, merely a pointer to a particular memory location. So let's say you have some data stored. Let's say I have a data stored. This is my memory location. Let's say 42 is the value. And A is the variable. When we assign A equals to, we'll also learn how to assign values. So let's say we assign the value A equals to 2. Or let's say, A equals to 42. So what happens? A pointer A is created and it points the value to this particular memory place. Let us assume that we again create another variable called B, having the same value 42. Then what necessarily happens is another pointer B is created, which points the value to the same memory place, that is 42. Therefore, we cannot actually call it a container. This is a container A containing value 42. This is a container B containing the value 42. No. Basically, these were pointers pointing at this particular memory place where the value 42 has been stored. This is very, very important, this particular concept, because this is how we reduce the time and space complexity. We'll understand much of it as we move forward. All right. Now, also one more thing to note is here. Let's say we again assign A to be 5. What happens then? This particular pointer gets destroyed, this arrow. Another memory place where 5 has been put gets assigned, and A now points at this particular memory place. That is how Python actually works. I hope you get this point clear. Now, so basically, a variable is a location in memory used to store some data. They are given unique names to differentiate between the different memory locations. Now, reserved words are something that you should never use as variables. Python contains some reserved words which have been listed over here. These are something that can never be used as variables. We can use A as variable, but we cannot use AND as variable. Or, for that matter, none of what has been mentioned over here. All right. Why do we restrict ourselves from using these particular keywords? Because these keywords have other usage. And once these are called, the computer itself, Python itself, understands that some different tasks needed to be performed. So it cannot actually recollect that what you exactly want it to do. Therefore, we generally restrict ourselves with very common keywords, or X, Y, A, B, C, and other stuff. We'll again understand all these things. These are not very difficult to understand. Okay. So let's move to the next slide. How do we declare a variable? Python doesn't need explicit declaration of variables. The declaration happens automatically as we assign value to it. What it means is, if A is a number which is equal to 42, what we do is A equals to 42. It understands that A is a number, is an integer. Again, if A is a string, that is a letter, a group of words, let's say hello, Then what we do is we write a equals to hello inside the parenthesis, which may be double parenthesis or single parenthesis, whatever works. Both are same. Now, note, we never actually declared that a should be an integer or a should be a string. The Python language itself understands that when you write 42, it understands the user needs a to be a integer variable. When you write something inside the parenthesis, it understands that you need it to be used as a string variable. You can also write 42 inside a parenthesis, and in that case, it would treat 42 as a string, not as a number. And do remember, in that case, you cannot use it as a number. You cannot add, subtract, or perform any mathematical operations. It would only mean a simple string. All right. So the equal sign is used to assign the variables as I have shown. All right. Now, so I have given an example. Here x is the variable and equal to is the assignment and 1 is the value over here. All right. So the rules for naming variables. There are some rules that needs to be followed. A variable name must start with a letter or underscore. So this is correct. It is started with a letter, and this one is starting with an underscore. So both are correct. However, it cannot start with a number. For example, this particular thing here, a number has been given at the preface, and it cannot be a particular form of a variable. Either you started with a letter or an underscore. Both are correct. You cannot necessarily start with a number. The third and most important point that no variable can contain any characters other than alphanumeric characters. It can either contain a number or an alphabet, nothing else, except an underscore. Underscore is something that a variable can use. Other than that, any numbers or any string or alphabet, whatever you want to call it, nothing else. So at the rate, for example, is incorrect. Here, had you used an underscore, it would have been absolutely correct. You cannot rather use any other symbols inside, let's say this d at the rate ATA. This is again wrong. So no symbols can be used other than an underscore. All right. Now, having learned this, let's perform some lab assessments. So let's start with the Python fundamentals part. All right. So the first thing that we want to do is check our Python version in the Jupyter Notebook. For that, you need to type these two particular commands: import sys, sys, sys.version. So when you press Control and Enter, this is what it shows for me. If you have downloaded the latest version, it would be showing the same for you. Otherwise, let's say if you're using this particular course at a much time ahead in future, it might be showing some future versions as well. All right. Now, let's get into this particular topic of Python variables. So as I've already mentioned, variable is a location memory used to store some data. They are given unique names to differentiate between the different memory locations. Now what happens over here is, I have assigned x to be 3 and y to be 3. I've only told you in theory what happens. Now let's check if I were right or if I was just playing. So one good function of in Python is id. So when I write id of x, it gives me, as I told, that this is a memory place, and here the number 3 has been located. Now x is, as I said, is pointing over here, y is pointing over here, correct? Now when I write id of x, what it necessarily does is, it gives me the location where x is pointing. All right. Similarly, when I write id of y, it gives me the location where y is pointing. So let's check. All right. Now let's see. Now id of x is showing 12172202745444. id of y is showing the exact same. Both are exactly the same. Just check it out. Why? Because both x and y points to the same memory location, that is where 3 has been stored. Now, in the next step, what I do is, I have changed y to 2. Therefore, what necessarily happened was, previously, there was this memory location, x and y were pointing to it. Now, what has happened is, there came another memory location where 2 has been stored, and y is now pointing at this particular memory location. Therefore, id of y after the memory location has been changed is, see, it has changed, 12172202745. Up to that, it is same. While the first two has 44, this one has 12 in it. So it has changed. Now, we do not really need to go deep into it, that why, what, how the numbers are created. These are simple RAM memory spaces, and this is how the values are assigned. The thing that needed to be noticed was that these are not containers. Had it been containers, the numbers would have been same for y and same for all the x, and different for x and y. However, here the numbers are same for x and y, but different for the values that has been stored. Hence, the theoretical part that I had been saying is proved to be true. All right. Now let's understand the keywords that I was talking about. So keywords, what are they? They are reserved words in Python. We can't use a keyword as variable name or function name or any other identifier. Keywords are also case sensitive. All right. Now, you do not need to really understand what this code is. Just understand what I'm doing is, I'm importing a library called keyword, and I'm just giving you out the list of keywords that are present in Python. So these are the list of keywords that we have in Python. And how many keywords are there? These are 36. So there are 36 keywords that cannot be used as variables, function names, or anything. All right. Also do understand that Python, the language Python, is case sensitive. That is, capital A and small a has different meanings. All right. Now coming to the next part, where we are declaring variables. So as I said, to declare variables, we use this particular symbol equal to. So a equal to 3, b equals to Python, c equals to 5.7. Print a, b, c. This is how we print. When we printed it, it says 3, Python, 5.7. Now, an efficient way to declare all the variables, if we have multiple variables and we need to declare them, what we do is, we line up the variables one by one. Here what I have done is a, b, c equals to 3, Python, 5.7. And I've printed them. The same result is what we get. Now for beginners, this is not something that I will be recommending. But as we go ahead, as we progress, this is something that we can use to save some amount of time. All right. Now, let's understand what scope of variables means. So I'll be pulling my, so scope of variables. Scope is basically the part of the program where the variable is accessible. There are basically two types of scopes, local and global. Local scopes are, okay, let's understand in this way that when we create a function, we do declare some variables inside it. We'll understand what functions are basically, but for now, functions are pieces of code which perform collectively a particular operation. Let me make you understand this by practical exposure. Okay. So what is happening over here? I have written this particular function, def. I've given a function name. We'll be understanding how we create a function. And I have given this name, the variable, that is var equals to 4. Now I'm calling this function, all okay. And now I'm printing, print var. It is giving me an error. Why it is doing so? If I called it, let's say if I call the same thing over here. Okay. See, the value 4 is being called. Why is it so? Because this is a local variable and it can be called locally inside the function. But when I'm not calling it locally, when I'm calling outside the function, it is giving me an error. The reason is very simple. Everything that occurs inside the function is a closed, consider it as a closed room. You cannot access this particular room. And everything outside is the global space. All right. So what is a global scope? A global scope is when the variables created inside the main body of Python code. All right. So what happens over here is I have created another variable called var2, which is equals to 6. Now I'm creating another function, var equals to 4. And now what I'm doing is I'm also creating, I'm calling this particular function and I'm printing var2. Now when I'm calling var2, it's printing 6. So this is how it prints. Why? Because now it does not really needs to enter this particular room, this concealed room. It can find var2 outside this particular concealed room here. That's why it can print. Now let's say var, okay, let's make you understand it even more. Let me put the same value outside, var4 equals to 4. All right. If I had done this, what is your expectation? What would have we got? Nothing but the same thing. Okay, let me change it over here as well. So we would have got 4 as the answer. This 4 is coming from this part, not this part. If var equals to 5, we will be getting 5 as the answer. All right. Now, one very important thing to understand over here is the priority of scopes. So local scopes has more priority than global scopes. How do we understand it? See, here we have written var equals to 6. And here, inside this closed concealed room, we are given var equals to 4. Now, when we print var, it actually gives me 4, the value 4. That's what happens. See, 4. And for the second print, var, it gives me 6. Let's say I commented it. So Putting a hashtag in front of any line gives me comments that particular line out. That is, it becomes non-executable. So see, when I stop this from execution, the value we get is 6. That is this one. Because this is a closed concealed room, var equals to 4 cannot be accessed. var equals to 6, that is outside the room, is getting accessed. However, when we conceal this particular print and open this one, what we get over here is a 4. Why? Because inside this function, both var equals to 4 and var equals to 6 is getting registered. However, since the priority of local scope is greater than global scope, between var equals to 4 and 6, it chooses var equals to 4 because var equals to 4 is a local scope, the local function. To understand it more clearly, had we commented this var equals to 4, we have got a var equals to 6. As I said, inside this particular function, both var equals to 4 and var equals to 6 is accessed. However, since local scope is greater than global scope, it chose var equals to 4. Now that var equals to 4 does not exist anymore, it chooses the global scope. All right? I hope you understand each and everything because it was really very important for you guys to understand. All right? Now, one more important thing that we can do is declare global variables inside a function. How do we do that? Once we call the function, and before declaring the variable, we write global and the name of the variable. So the name of the variable is var. Before that, we have introduced another keyword called global. So global var. It now creates the var not as a local variable, but as a global one. How do we know about that? So inside this closed room, var has been declared. And we are calling this function outside. Still, we are getting the value 22. Only because we have declared it as a global variable. So these were the tits and bits. What did we learn? The scope of local variable and scope of global variable. How can we declare a global variable inside a function? And the priority of local variable is more than that of global variable. All right. Now let's come into the part where we deal with the data types. So every value in Python has a data type. Data type is nothing but, as I said, string, integer, and everything. Now, one important thing that we need to understand is everything, and I repeat, everything in Python is an object, because Python is made in such a way that it is an object-oriented program. So everything inside a Python is an object, and every data types are actually instances of these objects. All right? And that is the reason you find here class integer, class float, class complex. So since everything is an instance of an object, what we'll be considering is the second half. That is integer, float, string, boolean, and everything. All right? Now let's understand how it actually works. So I've declared a equals to 5. And we very well know that 5 is an integer, right? Therefore, when we print the type, and how do we know what kind of a data type it is? We know by the keyword type. What we essentially do is, let's say we have declared a variable a equals to 5. To know the data type of a, we write type of a. And we get class, because it's an object-oriented programming, and what kind of instance it is, that is int. So I've written a equals to 5. The type of a is integer. B is equal to 5.5. 5.5 is not an integer anymore. It is a decimal number, which in Python we call as float. C equals to 1 plus 2j. For people belonging from mathematics background, you must have heard about complex numbers. A plus IB, this is the form it takes, or x plus IY. So in Python or in electrical engineering for the engineers, we write it as 1 plus 2, x plus IJ, x plus YJ. So that's how in Python it is written, 1 plus 2j. This is the real part and this is the imaginary part. And the type of C is complex. We can also extract the imaginary and the real part as well. D equals to hello, which is a string. And that is the reason it is giving me str. Str stands for string in Python. There's another important data type which deals with true and false only. Okay. So it deals with true and false. These are called Boolean. And is represented as BOOL, bool. So true is a Boolean data type. All right, moving forward, what is typecasting? Now, let's say I have introduced a variable x, which points to 5, which is an integer, right? So I can know that this is an integer by printing the type. Yes, it shows it is an integer. Now let's say I want this 5 to be a string. How can I do so? There are basically two ways. One is that what I do is I write x is equal to 5. In this case, it would be taking 5 as a string. But what if I have already declared x is equal to 5 and I want to change it to a, let's say, string? We do something called as typecasting. What I do is I write str of x. And I can enclose it within another variable, that is y. So y is equal to str of x. Now, when I print its type of y, it should give me a string. So that's what has happened over here. Firstly, I had introduced x is equal to 5, which is an integer. That's what it shows. Now I had typecasted it to string. So y is equal to string of x. Now print type of y gives me string. All right. Now typecasting has different methods. Not only we can typecast an integer to string, we can typecast a string to integer as well. For that, we do have the minimum requisition. That is, it should be somewhat like an integer. We cannot necessarily typecast a string called 5.5 to integer. Then it can be typecasted to a float maybe. All right. Now, let's go to the next section called operators. We have a total of 6 operators in Python. Now, there is nothing to be overwhelmed of. All the 6 are very easy if we bring our logic into being. The first one is called arithmetic operator. The second is called assignment operator, comparison operator, logical operators, identity operator, and membership operators. Now, starting with arithmetic operators. This is nothing but contains all the arithmetic operations inside it, like addition, subtraction, multiplication, division. Is something called as float division, exponent, and modulus. So let's understand each one by one. All right. So I've taken 2 variables, that is 5 and 3. Addition is simple. We write x plus y. Again, let me clear it out. You might have been seeing all these things all along. What is this? Let me create another cell for you. So for addition, what we need to do is essentially, first we need to call it. First, let me assign x, the value of x and y. Then if we need to add, what we do is x plus y. It gives me 8. If I do a subtraction, x minus y, it gives me 5 minus 3, that is 2. If we do a multiplication, x into y, it gives me 15, that is 5 into 3, 15. What if I want to do a division? 5 divided by 3, we'll get the quotient. I'm sorry, we'll get the entire thing. That is 1.667, right? Now, float division or integer division, this particular thing, is nothing. We put 2 division signs or backslash, whatever you want to call it. And then in that case, it gives us the quotient. That is 1. 1 point something, so it will be giving us the quotient part, 1. The remainder, it won't be giving us. All right? And there's something called as exponent as well. Exponent is to the power. So 5 to the power 3 is 125, I guess. 5 into 5 square is 25, and 25 into 5 is 125. Okay, so there should be 2 stars for that. 5, and it's giving us 125. What is modulus? Modulus is basically taking the remainder part. So 5 divided by 3 gives us a remainder of 2, right? Quotient is 1 and remainder is 2. That's what it does. So I hope you understood the arithmetic operators. Now, this is something I'll let you understand this as well. What it does is, when we write the print statement, print, print, we need to put the brackets, and everything we want it to print inside should be done inside a parenthesis. So what I've written, addition, 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 and it prints the addition. All right. What if I want to print a value of 5 with it? After addition, I put a comma and then x. Now it will print addition 5. I hope you got the point. So that's what it is doing over here. X plus y is the sum, that is 8. Addition, after that an arrow sign followed by a comma and x plus y. That's what it has done. Addition is 8. Subtraction is 2. Multiplication is 15. Division is this. Integer division is 1. Exponent is 125 and modulus is 2. All these things I have written. I hope you get an overview how I have used the print statement. This is something that we'll be using widely in data science as well. All right. Now coming to the assignment operators. As I've already let you understand that this is how we assign. Let's say we want to add 2 numbers, x and y. So I have what I've done is I have assigned them. X and y is 5 and 3. X is equal to x plus y. That is 8. Print x. So x is equal to 8. What we could also have done here, instead of x is equal to x plus y, we could have written x plus equals to y. So let me grab the pen real quick and explain. So x equals to x plus y can also be written as x plus equals to y. What does it do? See, if you're a beginner and you do not quite understand it, or you feel overwhelmed by this particular form, no problem at all. Use this one instead. This is absolutely good. But this is something you might be seeing in other people codes, or you need to understand what it is. And in later, I can assure you that you'd be using this particular format, x plus equals to y. But for beginner, you can use this to start with. So let me make you understand what it is basically. So x plus equals to means, okay, plus equals to means x plus. It actually means equals to x plus something. That's what I've done. X equals to x plus y. X plus equals to y. So instead of x plus, I've used plus just before this equal to sign. It is meaning x plus. Did you get my point? So basically, x is equal to x plus y. We can write it as x plus equals to y. Whenever you see any variable plus equals to any variable, it can be 2 as well. Let's say a constant number 5. It means x is getting added every time by a constant number 5. X is equal to x plus 5. So x equals to x plus 5. That in short can be written as x plus equals to 5. That's what I've done. X is equal to x plus y. Here I've done the same thing. X plus equals to y. Print x, that is 8. Alright? Now, comparison operators. What are these? Comparison operators basically consist of, they are used to compare values with one another. And the result is in Boolean. It is either true or false. The following are the basically comparison operators. Double equal to, which means it compares if this particular value is this particular value, equal to or not. Not equal to, we put a exclamation mark before equal to, and that means not equal to, greater than, less than, and greater than equal to, less than equal to. So let's understand one by one. So equal to, print 2 equal to 2. Is it true or not? Yes, 2 is equal to 2. So again, do note one thing. We do not write 2 equal to 2. Why? Because equal to in Python is basically assignment. X is equal to 2 means x points to the memory location 2. But x equals to 2 means it is a logical operator which checks if x equals to 2 or not. Alright? So here 2 equal to 2 is true. Again, 2 not equal to 5, it is true. 2 is not equal to 5 and hence it is true as well. Greater than, 4 is greater than 2. Again, it's true. Greater than equal to, we put an equal to sign after the greater than sign. So 4 greater than equal to 4. Is it true? Yes, it is also true. 4 is not greater than 4, but 4 is equal to 4. So it falls in the same range. That is 4 is greater than equal to 4. Next, less than. 2 is less than 6. This is correct as well. And 6 is less than equal to 8, which is again true. 6 is not equal to 8, but 6 is lesser than 8. So, okay. Now we come to the logical operators, which consist of only 3 things: and, or, and not. So we'll understand how to use it. It is again very, very important. So we use this to combine things. In English, as we call it as conjunctions. So and, what we do? I have assigned x to 5. So x equals to 5. Now I'm giving a condition. Is it true or not? X greater than 2 and x less than 10. Is it true? Yes, it is definitely. Because 5 is definitely less than 10 and 5 is definitely greater than 2. So x is greater than 2 and x is less than 10. It's correct. And it's therefore giving me as true. For or, it's saying x equals to 5. X is greater than 2 or x is less than 4. Is it true? Is x greater than 2? Yes, x is greater than 2. Is x less than 4? No, x is not less than 4. X is greater than 4 as well. But since one of the condition has fulfilled, that is x is greater than 2, it gives me true. Now note one important difference between and or. For and, both the condition needs to be satisfied. For or, any one of the condition is satisfied, it gives us true. And not is simply the opposite of what has been mentioned. A is equal to true, not A will be false. That's what. Okay, now moving to identity operators. There are only two identity operators, is and is not. So is evaluates to true if the variable on either side of the operator points to the same object. Okay. And is not is just the reverse of that. So what I've done is x equals to 10 and y equals to 10. X is y. Is it true? Yes, it is true. As I have explained that this is the memory location, x and y. Both points to this particular memory place. And therefore, x is y is true. Yes, x is y. X is nothing else than y. And when I put y is equal to 20, so now y points to 20. So is x y? No, x is not y. So yes, x is not y is a true thing. Now you might have a little bit of confusion. If not, if you have been paying attention properly, you might have a confusion. What is the difference between x is y and x equals to y? This thing. Right? What is the difference? We'll come to that at the last. Let me make you understand once more. X is... Okay, let us reserve this for the last. The very last operator is membership operator, which consists of two things, in and not in. In evaluates to true if it finds a variable in the specified sequence. And not in is just the opposite of that. So let us consider a list. List is nothing but a storage sequence. It consists of all these numbers, 3, 6, 4, and 1. 3 in Li. So this list I have named as Li. Now my question is 3 present in Li? So I'll be writing it as 3 in Li. Yes, 3 is definitely present in Li. And therefore it gives me true. Now let's see, is 7 present in Li? No. And I've written 7 not in Li. Is it true? Yes, obviously 7 is not present in Li. And therefore we get true for that as well. Now coming to the most important doubt that you people might be having, what is the difference between equal to and is? Basically, equal to checks the equality and is checks the identity, that is the IDs. Now, when I write A equals to A, I consider two lists, A and B, both having 1, 2, 3 as the elements stored in it. Is A equal to B? Yes, A is equal to B. Why do I say so? Because both the lists are exactly same, containing 1, 2, and 3. But is A and B having the same ID? I doubt that. No. How do we know that? What we do is we check their IDs. So what I've done is I've checked the ID of A, 760, while the ID of B is 8160. 160 and this is 760, and the numbers before that is also different. So they do not have the same ID, as a result of which A is B is a false statement. Alright? So that's all for today. This was a brief introduction about the fundamentals of Python. We'll be learning more in subsequent classes.